very important. So if I'm looking at x plus 5, do I know if x plus 5 is positive or negative? No. Why does that matter with an inequality? If you have an inequality and you multiply by a negative on each side, what happens?
Switches the inequality.
It flips the inequality, right? But if you multiply it by a positive, does it change? No. So I can't multiply by x plus 5 because I don't know if x plus 5 is positive or negative, so I don't know if I would flip my inequality or not. So we're going to do something a little bit different. With these, our goal is going to be to get a single fraction on one side and 0 on the other. So our first problem here is set up like that. We have a fraction on one side, the other side of the inequality is 0. Then we are going to find what makes top and bottom equal to 0. So if I set the top equal to 0, if x minus 3 equals 0, we get positive 3. X plus 5 equals 0, we get negative 5. All right, if you think about, we have graphed these rational equations. So we could draw the whole graph of this. We know 3 would be an x-intercept because it's when the top is 0. 5 is going to be, or negative 5 is going to be a vertical asymptote. So you could certainly think of it like that. But that's probably a little more work than we have to do on these. So just relating it to what we've already done, we would have this information, but then we would have to find horizontal asymptotes and everything else if I were going to get the full graph, right? But these are the places where a graph is either 0 or undefined. That's the only way it can switch sides of the x-axis. Okay, so over here, it's either going to be above or below the x-axis on this side. You know, we can cross through the x-axis here, but otherwise it's above or below. So what we're going to do is make what's called a sign line. Okay, it's a simplified form. We don't have to have the entire graph in order to solve this. We just need to essentially know where is this graph positive or negative. So what I'm going to do is take these two numbers that I found and place them on a number line. You don't have to have a real exact number line. I'm just putting these numbers, smaller number on the left. So this is our sign line. Then we pick test points. So if I plug in a number, we need something smaller than negative 5. So what might be a number smaller than negative 5? Then we need a number in between negative 5 and 3. And then a number bigger than 3. Okay, these are my test points, so I'm not like putting tick marks and placing them on my number line. Those are just the numbers I'm going to be looking at. All I care about with these numbers is if this fraction is positive or negative. So if I put in a negative 6 minus 3 is a negative number. Negative 6 plus 5 is a negative number. If you take a negative divided by a negative, you get a positive. Now, could you use your calculator and get the exact number? Absolutely. So if you feel better with that, you can. But all I care about is it's positive. So I know that this graph was greater than 0 before I got to negative 5. Okay, that's all I need. If I put in 0, 0 minus 3 is a negative number. 0 plus 5 is positive. And negative divided by a positive is negative. So the next part of my graph, between negative 5 and 3, it was always negative, whatever that might look like on this particular graph. So maybe it did something like this. I don't even care about that graph. I just know it was below the x-axis. If I put in a 4, 4 minus 3 is a positive number. 4 plus 5 is positive. Positive divided by positive is positive. So I know that after this point, my graph was positive again. Now, is this my exact graph? Absolutely not, because I didn't find all my information. But what I care about here is just these signs. My question asked, when is this graph greater than 0? Greater than 0, is that positive or negative? Positive. So my graph was positive here. So these numbers work. So we will answer with an interval. Everything before negative 5 worked. So negative infinity to negative 5. If you plug in any number smaller than negative 5, you are going to get a positive answer. Or everything bigger than 3 works. This problem did not have an equal to. It was strictly greater than, so that's why everything is parentheses. Equal to's are brackets. Okay, so with the inequalities, our answers are intervals, and we have to use the sign line to decide if it's positive or negative. And why did I pick the positive answers for this? Because my inequality was greater than 0. Okay, that's a little bit different than problems we've solved in the past. What questions do you guys have for me there? Did I lose anybody? Yes.
How come you don't just plug in negative 5 and 3? Like, how come you?
You can, but if you put those in, we already found those are the points that make it 0. So if you put in negative 5, the bottom is 0, so it's undefined. So it's not positive or negative. If you put in 3, you get 0 divided by 8, which is 0. So 0 and negative 5 are either when the equation is 0 or undefined. It's not positive or negative there. Other questions? So this is the only thing we're doing today. We're just practicing these inequalities. So let's take a look at another one.
Will we do any more work with the equations or we kind of done?
If they're not in the correct format, we will have to do some work before we do our sign line. So I told you that.
Well, I bet like with what we did the other day. Cause I don't know.
Yeah, we can. I do have tomorrow. We're going to do some more practice with both equations and inequalities. So, all right. So with these, we have to have our goal one fraction on one side and 0 on the other. What's wrong with this? I have a fraction over here, but do I have 0 on this side? No. So I have to get it in the correct format before I can make my sign line. So if I subtract my 1 over. Okay, now it's 0, but I don't have a single fraction here. So we have to get a common denominator. 1 is like 1 over 1. So if I want my denominators to match, I'm going to have to multiply this times x plus 4 on top and bottom. So I'm going to create a common denominator to put those terms together. Since I'm subtracting, I will distribute that through this whole fraction on the numerator. Now the denominators match, so we can put them together into one fraction. So on the top, 5 plus negative x minus 4, so that would be 1 minus x. Okay. In order to get the sign line, we need to know what makes the top and bottom equal to 0. So if you set 1 minus x equal to 0, you get 1. If you set x plus 4 equal to 0, you get negative 4. So those are the numbers I'm going to use for my sign line. Smaller number on the left. Then we do our test points. So any number smaller than negative 4. Any number in between -4 and 1. And then any number bigger than 1. And I am plugging these in to this problem right here. And we had the fraction on one side, 0 on the other. So if I put in -5, 1 minus -5 would be 1 plus 5, so that's positive. -5 plus 4 is negative. If you take a positive divided by a negative, your answer is negative. If I put in a 0, 1 minus 0 is a positive number. 0 plus 4 is a positive number. A positive divided by a positive, positive. If I put in a 2, 1 minus 2 is negative. 2 plus 4 is positive. So that section is negative. I just want to caution you, most of the time these signs alternate, positive, negative, positive, but they don't have to. Didn't we see graphs that sometimes would hit the x-axis and bounce back up? So don't just assume that they'll always alternate. Go ahead and check all of them. Now we have to decide which ones we wanted. I said greater than or equal to 0. Greater than means positive or negative? Positive. This section of my graph was positive. Equal to tells me brackets. But if I write this, I'm actually wrong. I'm going to figure out why.
Because x plus 4 is a 0, and well, it's actually a 0 -4, so that means it can't be -4, so you have to put a parentheses there.
Yes. Remember when we were solving our equations, we always said in a fraction the denominator can't be 0. So when I look at this, x can't be -4 because that makes the whole thing undefined. So even though I said equal to, when I put in -4, I don't actually get 0, I get undefined. So the denominator always gets a parenthesis, no matter what. So because -4 was on the denominator, denominators can't be 0, it gets a parenthesis. The top of the fraction can be 0, so that one gets a bracket. So we do have to be a little bit careful there. Questions there? So what's the first step? Mm-hmm. Okay. 4 is like 4 over 1. In order to get a single fraction, we need a common denominator, so we have to multiply by the denominator. So I'm going to take this times 2x minus 3 on the top and bottom. So since we're subtracting, just do the negative. Then -5x plus 13 over 2x minus 3. So this is the fraction we are going to be using. We have to figure out what makes top and bottom equal to 0. Positive 13 this. And a positive 3 halves. So 13/5, that's like 2.6, so it's bigger. 3/2 is 1.5. So test points, smaller than 3/2? In between? And bigger. So I'm putting these into my fraction. If I put in a 1, -5 plus 13 is positive. 2 minus 3 is negative. Positive divided by negative, it's negative. If I put in a 2, -10 plus 13 is positive. 4 minus 3 is positive. 2 positives give us a positive. If I put in a 3, -15 plus 13 is negative. 6 minus 3 is positive. Negative divided by positive is negative. So now we look. This one was less than 0. That tells me I want negatives. There was no equal to, so I don't have to worry about the brackets. Everything just gets a parenthesis. It's negative infinity to 3/2. And then 13/5 to infinity. Any questions on this? Well, let's keep doing them. This one's a little bit different. Let's take a look at it. So we know the first thing we have to get 0 on one side. So in order to do that, we have to subtract this fraction over. These already have a common denominator, so can't I just put them together? 7 minus 1 is 6. 6 over x plus 2 is greater than or equal to 0. That's the fraction I'm going to be using. So this one was actually a little bit nicer. We didn't have to get the common denominator. It just happened for us. When we set the top and bottom to equal 0, does 6 ever equal 0? No, so that's not going to give us anything. If you set x plus 2 equal to 0, we get -2. So on our sign line, we actually only have one number to test, -2. So we need our test points on each side of that, so smaller than -2. 3, bigger than -2. Okay. If I put these in, 6 is positive, -3 plus 2 is negative. Positive divided by negative is negative. If I put in -1, 6 is positive, -1 plus 2 is positive. And 2 positives make a positive. Which answers did we want? Greater than. That means positives. It said equal to. Can I put a bracket on the -2? No. Why? Right, it's from the denominator. Even if I have an equal to, if it came from the denominator, it can't get a bracket. So my answer is just -2 to infinity with parentheses. Let's do, I'm gonna jump. Let's do this one. So where do we start? Now what do we need to do? We have to get a common denominator, but they have two different denominators. So the first one has x plus 1. To look like that, it needs x minus 3. This one has x minus 3. To look like the other one, it needs we have 4x minus 12 over x plus 1, x minus 3 minus 2x plus 2 over x plus 1, x minus 3. I distribute my negative. Four x minus 2x, we're giving me 2x. Negative 12 minus 2 is negative 14. Or x plus 1, x minus 3. So we had to get a single fraction on one side, 0 on the other. We have that now. If we set top and bottom equal to 0, that gives me a 7. If I set x plus 1, x minus 3 equals 0, we get negative 1 and positive 3. So I have 3 numbers. Put them in order on your number line. So negative 1, 3, and 7. Alright, we need a test point for every interval. So smaller than negative 1, in between 3 and 7, bigger than 7, 8. Okay, so if I put these in, I put in a negative 2. The top is negative. On the bottom I have a negative times a negative. 3 negatives would give us a, if I put in a 0, the top is negative, the bottom we get a positive times a negative. So that would be positive. If I put in a 5, 10 minus 14 is negative. 5 plus 1 is positive. 5 minus 3 is positive. So that section is negative. If I put in an 8, 16 minus 14 is positive. 8 plus 1 is positive. 8 minus 3 is positive. So that section is positive. Does everyone know how I decide the positives and negatives? Right. We wanted less than 0, which means negatives. No equal to, so we don't have to worry. Everything just gets parentheses. So my answer is negative infinity to negative 1. Union 3 to 7. What I want to do now is give you guys time to work so I can answer individual questions. Tomorrow we are just reviewing what we did Monday and today, so the equations and inequalities together. I'll review both of those tomorrow. Today there is a Math Excel assignment open with just these inequalities.